Hi, welcome back to our section, right, to our work. So the next part is Unit 5B, right, schedule belief statistical study, right? So some things need to be really careful about, right, when you do a statistical study. Right? Guidelines for evaluating a statistical study, right, is the following. Right? Identify the goal of the study, the population considered, and type of study. Consider the source, particularly with regard to whether the researchers may be biased. We're looking for bias that may prevent the sample being representative of the population. In other words, like if you want to, for instance, right, if you want to get an average height of PMCC, right? What you're trying to prevent is not go observing those volleyball team, right, or those basketball team, right? Those are super biased, right? Those average height usually will be much higher than uh, normal people, right? Either male or women that will be far away from the true population, right? Represent, right? So that is the thing. Right, then look for the problem defining or measuring in the variables of interest, which can make it difficult to interpret results. Watch out for confounding variables that invalidate the conclusions of study. Consider the setting and the wording of questions and a survey, looking for anything that might tend to produce inaccurate or dishonest responses. Check the results are presented fairly in graphs and concluding statements, since both researchers and media often create misleading graphics or jump to conclusions that results do not support. Stand back and consider the conclusion. Did the study achieve its goals? Do the conclusion make sense? Do the results have any particular practical significance? Those are all the things we need to worry about when we're doing actual study, statistical study work. Right. So for your information still, right? Still is just for your information. Well, as I usually says to my other classes, right? The data collecting part is actually the hardest part. And our course here is just give us a brief idea of how to deal with the data, assuming all the collecting point is preventing all the biases or preventing all other noises, right, of the study, making like just all the results are what are promised, right, are pretty promising. Right? That all the data from the sample will be a good representative of the population, in other words, right, in the sentence you can see here. Representative of the population, right? Will be very representative of the population. Right, still let me use back the yellow color. Okay. Representative of the population. Oh, that sounds easy, but a lot of things behind it, those statisticians need to worry about. Right, that's actually the hardest part, as I usually say. After collecting data, the calculation or the skills everyone like with those ideas should be know it already. I should be very familiar with it. Should be very familiar with. But actually, the preparation is actually very hard. Okay. All right. The next part we move on right to statistics. So statistical tables and graphs. All right. So first of all, types of data. All right, there are two types: quantitative and the qualitative. Quantitative, in other words, is a numerical data. They are numbers, represents counts or measurements. And the qualitative data, there are, in other words, it's called categorical. There are names, labels. Numbers are not representing counts or measurements, right? So for quantitative data, could be numbers. Qualitative data, some case could also be numbers, right? It in other cases could be the label, right? Or identification. That's the purpose. Those numbers not representing the counts or measurements. But for the numerical data and the quantitative data, that numbers actually represents the counts or measurements, right? So I put here in red, right, to be very specifically showing you the importance of it, right? When the numbers have to be representing the counts and measurements, then it's quantitative. Otherwise, even though for some numbers could be qualitative while they don't represent counts or measurements, right? So let's see, an example, either quantitative or qualitative. When you write down numerical or categorical, that's also fine. Right, so the first one, the age in years of survey respondents. Right, the age is a number, like for someone, maybe respond he or she is 50. That ages is just a count of how many years he or she lives, right, in basically, right? So that is a quantity, right? Quantitative. Right? So this data is quantitative, the age of a person. Oh, the political party affiliations, they are just names, right? Democrat, Republican, Independent, or other things, a survey respondent, they're just names, right? It's not number. So if a thing is not number, that have to be qualitative. And the last thing, well, the social security number. Right, this number, of course, is made up, right? If someone has this number, I'm so sorry, I will change it. But yeah, that one is, of course, made up. Right, the social security numbers, even though that's a number, right? But that number is not a measurement, it's not a count. Right? It has some meaning, but it's more or less it's just what? More or less it's just a identification, right? That's it's just helps the government or whoever else, right, concerning that will be able to identify the person. Right? It's nothing else but just identification, right? It's not used for measurement. It's not used for counting. Right? It's just a qualitative data. It's not a quantity, right? It's just a qualitative. Any type of your ID number, like your universal ID number, your social security number, your driver license ID number, your whatever ID number, right? Those are numbers, but they are qualitative, right? Even though your license plate, right, contains some number, right, or letters, but of course they are all qualitative data, right? The labels on the person, right, on the player, basketball player or soccer player or football player, right? They're all qualitative data, just showing the audience or people who the person is. Right? It's nothing by measurement, nothing by counts. Right. So that's about quantitative and qualitative data. Next topic, the frequency table. A frequency table has two columns. The first column lists all the categories of data. The second column lists the frequency of each category, which is the number of times each category appears in a data set. The additional column includes the relative frequency. That's frequency expressed as a fraction of the percentage or percentage of the total, or cumulative frequency, which is the total of the frequency for the given category and all previous categories. All right, so let's see. So the example here, relative and cumulative frequency, attach that, right? So for a class having grade A, B, C, D, and F, right? Frequency means that 4 students got grade A, that 7 students got B, 9 students got C, 3 students got D, and 2 students failed. Total of the frequency is meaningful. That means there are 25 students in the class, right? That means there are 25 students in the class. And relative frequency may be attached right here. The relative frequency will be just showing you the percentage, right? From 4, 7, 9, 3, 2, we can see, well, that C has the most students got, right? 9 students from 25 students got C. But that's the only thing, right? The least, well, that's only 2 students got an F. For the relative frequency, what we can see is the percentage, right, of the total. 4 students got A out of 25 students, which we do the division, 4 divided by 25 to get 0.16, and that's 16%. That 7 students got B, so we do the division from 7 divided by 25, the total, right? 7 divided by 25, that's 28%. So on, right? The idea will be same. That 16% got A, 28% of the students got B, 36%, which is the majority, right, got C, 12% got D, and 8% got F. The total of the relative frequency should be 100%, or 100% of the 100% of the students in the class have to be got a grade. Right? Cumulative frequency, in other words, I mean, not on the other hand, right, is tells the partial sum, right? In other words, the partial sum. We can see, well, that's 4 students got the A. That's 4 and 7, that's 11 students got B or better. 9 more students has C, so there will be 20 students in total got C or better. Right? And the 3 more got D, so that's 23 students. Right? Attach another 3 to the previous one, right? So it's kind of adding 7, adding 9, adding 3, adding 2 to the previous partial sums. 9 plus 7 plus 4 is nothing else than 9 plus the 11, right? 11 is the sum of the first 2 categories, so adding another 9 to get the subtotal of the first 3 category. Right, so that's 23 students who got D or better, and there are in total 25 students, right? In total 25 students. Right, so provided the table of grades, well, you are able to find relative frequency and the cumulative frequency. Right, double check of your work. Relative frequency should be 100%. Cumulative frequency, the last row should be equal to the total. Right, but that is frequency for a single item, right? Single of subject. We also usually deal with the group frequency table. Like quantitative data categories, it's often used for to group or bin the data into the categories that have a range of possible values, because the number is usually a lot, right? So for single number, maybe it's not repeating that often. So using a group or a bin uh, to group the data together would be a better idea to representing the quantitative data, like here. Right, the following 20 scores from a 100-point exam. Scores are 22, 22, 22, 20, 72, 72, 72, 74, 75, 74, all the way to 98. That's 20 scores. And the categories break from 95 to 99, 90 to 94, like a gap of 4, and which is the size of 5 points, right? 95, 96, 97, 98, 99, right? That's the size of 5 points, all the way from 95 to 99 to 70 to 74. And the frequency you can double check, right? That's one student getting 95 to 99. That's still two students having score 90 to 94, and so on. Right, so that's how we build the table. Right, 90 to 94, 85 to 89, that is what? 85 to 89, that's 1, 2, 3 students. From 80 to 84, that's 3 students. 75 to 79, just count, right? 79, 8, 7, 6, 6, 5, 5, that's 7 students. And then the 4 students got from 70 to 74, right? You just add it up to check, oh, that's 20 students provided before. Relative frequency, if asked, that's just to use each frequency divided by total, convert to the percentage. Total percentage should be 100%, and the frequency of the cumulative frequency, the column, is just a partial sum, right? 1 is the first column, add a 2, that's score 90 and higher, and another 3, that will be 6 of the students had at least 85, right? That's another 3, that will be 9 students has at least 80, right? 7 more, that is 16 students together has scored at least 75, and the 70 above, that's all the 20 students have a score above 20, above 70. Right, so that is in the case the relative frequency and the cumulative frequency. But when you change from the individual data to the group data, you will be told about how to group it, right? Then for the frequency, you just count it yourself. Right, then we have a histogram and a line chart. A histogram is a bar graph of quantitative data categories. The bar have a natural order, and the bar's width has specific meaning. Line chart shows the data value for each category as a dot, and the dots are connected with lines for each dot. The horizontal position is the center of the group. It represents the vertical position, is the data value. The center of the group it represents. And the vertical position is the data value of the group. Right, so for the table we see from 70 to 74 all the way to 95 to 100, that is the frequency of 47331. We have the exam score, 70 to 75 to 80 to 85 look like each group have 5 scores, right? Has a gap of 5. So 95, then the last one will go to 100, right? So just a gap of 5, you will see naturally the pattern what is the last one will be, right? If you put 99, that will be a little bit weird, right? And the frequency, that's 4, 7, 3, 3, and 2, 1, right? So that is the table you're gonna draw, right? Of course, this is pulled out from the picture, right? So very clear, nice drawing, right? If you draw it yourself, maybe you need to specify other things, right? Then for the line graph, just use the midpoint, right? You can always like attach the two graphs together. Line graph, just connect the midpoint all the way and go down to the left and go down to the right. So it's like when you're connecting, it will be able to connect the midpoint, right, of each group, then just go down to the right, go down to the left, wherever it goes, that will be good enough, right? But the height and the point will be the same height as the histogram bars, and each point will be the middle of the histogram bars, right? So you don't have to do too much work on it, just connect lines, right? Use straight line, of course. I don't have a ruler on my computer, so that's what it is, right? That's how to do the histogram and line graph based on the table, right? Just use the left endpoint and attach the last group right endpoint, right? Using the frequency, using the pattern we have. Right, then example, the IQ score of 20 children lived near a lead smelter, whose blood lead level are less than 40 milligram per 100 milliliter. Right, so that's called a low lead group, right? That is not that high lead concentration, right? Low lead concentration group. And those are 20 children's IQ score, right? 11, 12, 13, 14, for 20 of them, right? And we use the frequency table to draw the group of 50 to 69, 70 to 89, and so on. That will be enabled to cover all the groups, right? So we have the IQ score group. We will have the frequency. Right, 50 to 69, 70 to 89, right, 90 to 109, 110 to 129, right? That will be everyone. And the last row is not part of the table, it's just show the total, right? So make it a solid line to separate a little bit from the table. All right, let me use another color to draw it. All right. So IQ score, that's 50 to 69, 70 to 89, right? Look like a gap of 20, right? 90 to 109, 110 to 129. All right, and we count. How many are having IQ score from 50 to 69? Look like just two of them. 70 to 89, we have 1, 2, 3, 4, 5, 6, 6 of them. From 90 to 109, 1, 2, 3, 4, 5, 6, 7, 8. Right, and finally 110 to 129, 1, 2, 3, 4. Right, 4 of them. The total has to be 20, right? 8 plus 8 plus 4. That is the 20. Okay, right, so that's good. Then we draw what? We draw the frequency table we draw the histogram and the line chart together to display the group data. All right. Oh, okay. Vertical line, horizontal line. All right, not that horizontal, but let me try to make the best I can. All right, that's the best I can do. All right, good. So the horizontal line represents the IQ score. The vertical line represents the frequency. Right, just like the score before is representing the scores and the frequency, right, for the exam score. Here is the IQ score. 4 groups, right, from 50, 70, right, 90, 110, and what? 129, but based on the pattern has gap of 20, we have 130 of the IQ score. Right, and the horizontal scale goes all the way just up to 8. Right, so we can make a gap 1, 2, 3, 4, 5, 6, 7, and 8. Right, label that. Right, up to 8. Then we have what? The first group from 50 to 69 has 2 children, right? Two children. We can shade it. 2 children. The next group has 6 of them, right? Just go up to 6. Go up to 6, right? Just shade it again. The next group has 8 children from 90 to 110. Right. Right, shade again. The last group has 110 to 130 or to 129. That's 4 children. Right. Shade it. And also we need what? We need the line chart. Line chart, just take the middle point, take the middle point of each of the bar, right? And connect them. Connect to straight line. Go left a little bit, go right a little bit down to the x-axis, right? To the horizontal axis, right? That will be it for the histogram and a line chart, right? So you will need more practice. If you want, you could redo this question to draw the graph, see what happens, right? When you draw it, you will see. And this question also, when you draw it, when you make it, when you practice it, you'll get a better idea, right, what that will be. Okay. The next part is about the correlation. A correlation exists between 2 variables when higher value of one variable consistently go with higher value of another, or higher value of one variable consistently go with lower value of another. Right, there is a correlation between the variables height and weight of people. That is, the taller people tends to weigh more than shorter people. There is a correlation between the variables demand of apples and the price of Apple, right? Demand and the price. That is, demand tends to decrease as the prices increase, right? That's usual. There's a correlation between practice time and the skill among piano players, right? That is, those who practice more tend to be more skilled, right? But that's a correlation, right? Every persons or every individuals or every economic cases will be different. So it's just a correlation, right? Just a correlation. It's one affect each other another, but yeah, that's it, right? Right, the scatter plot or scatter diagram is a graph which each point represents the values of two variables. Right, higher weights generally goes with high price, so positive correlation. That's a scatter diagram of diamond weights and its price. Right, the carrots. Of course, other like how clear it is. Do that have any scratches or something? Also matters, right? It doesn't necessarily like larger weights yields to absolutely the larger prices. We can see like about here, right? 1.7 or 1.6. Carter has the highest price, but this 2 point something is even lower than those diamonds, not that much weight, right? So some other factors may be taking place. So generally, but it's a positive correlation, right? The higher yields to a higher price. So you can see that dot could be means the diamond is 1 carat and its price is about 4,000. Right here is also a 1 carat diamond. Its price is about 9,500, right? So that is the dots and tends to goes increase. The prices tends go to increase when the weight is higher. Right, the next figure is a scatter diagram for life expectancy, and the infant mortality. Right, higher life expectancy generally goes with lower infant mortality. So this is a negative correlation. We can see different nations, life expectancy in Russia, that's about what 63, and the infant infant mortality deaths per 100 live births. Right, that's about 25 or 26, right, in Russia. South Korea, life expectancy longer, but and infants rate is getting lower. Right? In Bangladesh, that's life expectancy is low and the infant's mortality rate is high. Right, so that's Israel, whatever, Canada, Australia, those things over here, life expectancy is high, and the infant's mortality rate is low, right? Those things. So that's negatively correlation. Of course, other effects matters, but that's what we have. Right, and some case, right, we have here especially that is the linear correlation we can see, right? The linear correlation or linear relationship between two data variables where there is no correlation means, well, there is no apparent relationship between two variables. Positive correlation, that means both variables tends to increase or decrease together. Negative correlation means the two variables tends to change in opposite direction with one increasing while the other decreases. And the strength of correlation, the more close to variable follow general trends, the stronger the correlation is, which may be either positive or relative or negative, doesn't matter, but that close together, the trend, right, will be stronger correlation. Imperfect correlation, all data points lies on the straight line. Right? And we will touch more about the linear correlation in our chapter 9, right, in later chapters. That's just here a brief idea what they look like, right, what they look like. All right, so thank you.